Recording is on.
Okay, so lesson number 9 of Stackademic. Welcome back. Today we are going to talk about, I wanted to show you some more internals regarding the JavaScript. So even if I told you that we were talking about OOP, this will be related to OOP, but partially because the main topic is seeing some more JavaScript internals, right? So can you confirm, chat, that you can see my screen properly and that you can hear me properly? Yes, perfect. So let's start. Okay, so this is one of the old examples we had. Can you remember? That is a palindrome function. So let me start my environment. I got my file here. You should be very comfortable with this at this point. I don't know if you've seen that, but I have this extension for my console, which allows me to, see all command I can run. I might tell you about that more later. I'm using ZSH, so that's very useful. Let's start my live server.
Oh, Piero, can you just increase the screen of the
you're right.
code as well?
Does that look good now?
Looking good.
Thank you. So, okay, we have my code, and I wanted to show you one first thing. And to be honest, if this has happened to you, it will be really fun because this might be something super, super, super unexpected. And let me tell you more about it. Okay, so let me think about how I can go about this to show you also more about how JavaScript internals work. Yes, I have an idea. So, okay, let's just go. Okay, so suppose that you have two variables, right? And this might look like a very stupid thing, but it's not. And it's something very important, which can lead your application to huge problems. We got, let's say first person equal to Piero. And then we got a second person, which is equal to Sunil. And, let's just print those out, first person, and we say console.log, second person. Okay, let's see the result, Piero, Sunil. Great, right? Now, let's update this. And let's say that second person equal first person, because remember that here, when initializing a variable or assigning a value to it, you have to assign it an expression, right? What is an expression again? Something that produces a value. Calling this first person variable produces a value, so we can use it. So this should be like a normal syntax to you right now. Let's print again, first person, second person. What do you think is going to be printed? That should be easy. In both cases, Piero is going to be printed. Let's now do something more. And let's say that now I change my mind and second Piero is equal to Marco. It's a common Italian name. And then we print again those values. First person, second person. So you can see how both names initially were Piero, first person, second person. We printed them. Second person became Marco. So it's not Piero anymore. It's not the value contained inside of first person. And so we print them again. And then we have first person equal to Piero. We never change it. And second person equal to Marco. Keep this in mind, okay, right? Because now I'm going to show you something different, which can give you big, big problems. Now let's do first person as an object. And let's say that name equal Piero, right? And then we say second person, and let that be name Sunil. I'm doing exactly the thing that I did earlier. So, but instead of using normal variables, I'm using objects. And I print, I'm gonna just copy this, and then I print both the values. I uncomment this one. So we go an object and then the other. Now let's delete this, and let's say that second person is equal first person, right? So now I print them, and what do you expect to happen? First person and second person will both have a value as the name property of Piero. And that's it. Correct. Super lean, super clear right now. Are you sure? What will happen now? Second person, dot name, let's change my mind again, is Marco. And then I print this data again, okay? Did you see what happens? Did you spot the error? Can you see that I have two Marco right now? Why is that happening? Well, let's run through the outputs. The first output, Piero, is, yeah, okay. So basically, let me delete this thing, okay. The first thing we do is creating an object called Piero, first person, sorry, with a key value property of name Piero. We assign first person to second person, and then we update second person name. And we were expecting to have two different objects where in the first one we have Piero, and in the second one we have Marco. But that's not the case, because in the first one we also have Marco. How is that even possible? Well, this all comes back to how primitive values are stored compared to objects. You must understand that basically what I would like you to kind of get back to you from today's lesson is that everything is in JavaScript is an object, and we will see what that means. But right now we define objects, okay? So of course an object is an object, but when you memorize a primitive type, a primitive value, like number, a string, you don't have to worry about assigning a variables to another one, because basically when we go through this example here, I'm going to uncomment it. Inside of the memory of the program, a new memory slot is allocated for first person. So you will have, let's say, a memory slot at a certain index, and then, you know, at that index there is the value, which in this case is Piero, right? So when you do this, second person equal first person, simply what JavaScript does is allocate another variable inside of the memory, so another index, and then you have another one, which is called Piero. So these are two different variables in memory. But when you don't do that with primitive types, number, strings, Boolean, undefined, null, something different is happening, because when we go here, basically, and you create this object, how is this stored in memory? Well, at a certain index in memory, it stores, instead of a value, it stores another index, which points to the heap. A heap is a special memory part of our JavaScript programs where certain entities like objects are memorized. So, and then there is our value, let's say, so name equal Piero. So the problem is this, that at a certain let's say, memory slot in our JavaScript program, we are not storing directly the value like here, but we're storing an index that points to somewhere else where the value is stored. So when you're doing this, really what you're doing is storing an index. But since these two indexes are equal, they will point to the same value in the heap. So if you modify second person, you're also modifying first person. And similarly, if here we modify first person.name, you will see that the results are both Marco. Or if we do Sunil, the results are both Sunil. Why? Because we assign the index this value is storing to second person. So now, when I say first person.name, I'm referring to an index, then I'm accessing that value and modifying the name, right? But second person also stored this index, the same index. So when we retrieve it, we are retrieving the modified value. Was that clear to you, chat, right now? Perfect. So you gotta be really careful when working with objects because you might get some unexpected results. So also think that this kind of dialogue that we did right now also leads us to very common problems and a lot of resources online. So the first thing is that you got to be careful about how you copy objects, and there are also specific library like Lodash for doing this, because just remember that if you copy an object like this, you're really not creating another one. You're just storing an index inside another variable, so you're pointing at the same entity. So I suggest you go check out something called Lodash, and it's a library for common JavaScript operations, and you can see how you can solve this kind of problem. And please know that this problem also happens with arrays. Const array1, let's call it fruits. I want to play with emojis. Let's see if I got some cool emojis. I got some flags. Let's say is this a kiwi? What is this? I got kiwi, avocado, kiwi, avocado, strawberry. By the way, I prepared this for the lesson. Usually I don't use this emoji. Why would I send somebody an avocado? But anyway, let's use strawberry. Why it's not copying strawberry? Strawberry. And then I say const fruits. Let's say other fruits equal to fruits. And then I say other fruits 0 equal, and I modify that to be a peach. And then I console log fruits, and I console.log other fruits. You can see that both have a peach. So this was also fun because you just notice that you can use emojis when using JavaScript. So with arrays, you had the same problem, but it's easier to fix this because you can do something like enclose this and use the spread operator, which we saw in previous lessons. And you can see that now these are different because basically we are creating another array and spreading the first array values inside of the second one, which we just created. So this was the the workaround for copying arrays. So arrays, objects, be really, really careful. When people might ask you about a thing called pass by value and pass by reference when working with JavaScript, and so what they mean basically, it's a very common JavaScript interview question. They might tell you something like, what happens if I say const first name equal to Piero, and then I have my function logger, let's say, it takes in a name, first name, and then I say first name equal Sunil, and then I console.log first name, and I call logger, well, I don't need to store this like that. I just call logger with Piero, and you can see the logger will print Sunil, right? Super clear. But the thing is, oh no, I needed that variable, sorry. Thing is that logger prints Sunil, but here, if now I print first name, you will see that first name is still Piero. Why? Because basically we passed in a primitive value, so it wasn't modified inside of this function. And that's what people mean when they say pass by value. So you're passing an actual value, and so it kind of behaves like with primitive types, like we just saw. So that works. That's the same also when passing this value to function. So if you pass in a primitive value and you modify that inside of the function, nothing bad is going to happen because you're actually storing a value and not an index. But if I did first name, where name is Piero, and then I said first name, and I said, let's say person. And let's modify this to say person, and I pass in a person, and then I say person.name equals Sunil, and then I print person.name. You will see that we will see a double Sunil Why? Because this value gets passed, this object gets passed in, we're passing an index. And so basically you gotta just remember that always see this as an assignment. So basically it's assignment equal the value we're passing in. So value we're passing in. And so we are storing this again as a index. So when we modify this value, we are also modifying the external object, you know? So people might ask you, what is the difference by pass by? Is there pass by reference in JavaScript? And reality is no. You can just explain to answer this kind of interview question that the reason why person.name gets modified here and also outside is because of how objects are stored. There is no pass by reference in JavaScript, which is a mechanism in some languages, but it doesn't matter now. If they ask you, just tell that if you pass in primitive values, these values won't be modified, you know, like outside, and just you know now how they're stored. Is that clear, chat? Thank you for posting the Lodash link, Chantal. So another thing that I wanted to show you in this lesson, and it's kind of a big concept, but let me show you something like, can you remember when we used to do something like const array, let's say const numbers equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we say console.log numbers.filter. I'm just write a random function here, okay? So I'm just filtering all the numbers which are even, going from 1 to 10, right? You should be very comfortable with this right now, so I won't be going on over that again. But have you ever wondered where this filter is coming from? Have you ever wondered why, I'm doing the Italian gesture, why filter can be called on numbers as an object? We're really defining an array here, but as I told you, in JavaScript, really, everything is an object, including arrays. Let's try to solve this mystery slowly, and let's try to print our numbers and say numbers, right? I'm gonna remove this. You can see we printed our numbers, and you know, it's just a bunch of them. But if you look carefully, you will see that we got this proto property. And if you click on it in the console, you can see that we got a bunch of functions, entries, every, filter, flat, and we should also got, yeah, of course, filter. So this is where this method is coming from. It's coming from this proto. But what is proto? It's just weird. Apparently, this number has a property called proto, and we can do proto, and we can see it. There you go. So apparently, this number is an object. And I want to invite you also to go and say filter method in JavaScript, and you will see that if you go to the doc of JavaScript, you will also see something like array.prototype.filter. And this is the same if you go, for example, for map, array.prototype.map. So what is this prototype? And why now suddenly we are discovering that arrays are objects? Well, there is a super important mechanism that is going on in JavaScript. Basically, JavaScript doesn't support OOP in the sense of classes. OOP is a paradigm where, a coding paradigm where basically you define entities using something called objects, and then you create the program based on these objects interacting between each other, right? So for example, you could create an object which is called box. It has a height and a width, and then you, for example, can calculate the volume of this object. Or you can have, you know, something like a person, and you can calculate the age of this person. But JavaScript doesn't support OOP in that sense, but supports something called prototype inheritance. So again, we're talking about prototypes, and it's something very important about how JavaScript works behind the scenes. So let's try to build a circle around the concept of prototype to get back to this example here to understand what is happening here with numbers.proto. So let's try to use an example of object-oriented programming in JavaScript, right? So let's try to create our first object, right? And I'm talking to a different kind of object, and then create instances of the object. So in OP, the main concept is of creating objects, and these objects are shaped on certain things from the real world, and then we create instances of these objects which can interact. So for example, let me just show you. So how do we build a first example of OOP in JavaScript? Well, we use something called the Constructor Function. So let's say that we want to shape something from the real world, and we want to write a program where we are creating a person object. And then we are creating person starting from this blueprint. So basically we are creating an object and its instances. How you do that? You simply create a function, person equal function. Let's say that we want to define for every person a first name and then a birth year. And we want to say, I'm going to show you like now what happens. Let me just tell you that now we can say const Piero equal new person. My name is Piero and my birth year is 1999. So what is happening here? Well, we are using, let's say, the way in which we can build OOP in JavaScript, even if it's based on prototypes, and you will see that how it works like later. So basically, as I mentioned, I want to adopt this paradigm and shape an entity from reality, which is a person. I want to create a blueprint from this person. So every person has a name, has a birth year, has a surname. And then I want to be able to, can you please mute yourself, guys? And then I want to be able to use this blueprint to create instances of a person. So in my case, I want to be able to say something like const Sunil, and then I can say new person, and then I can say Sunil, and I don't know what year he was born, let's say 1990, if Sunil wants to tell us. And the way to do that in JavaScript is by basically using a constructor function, which is just really a function, and the new keyword. So basically, what's happening here, it's all thanks to this new keyword, because it's really letting a bunch of things happening behind the scenes. So when I create a new object using the new keyword and then a function, what is happening here is that an empty object is created. And if this doesn't all sound reasonable to you, you will see how this all fits in 5 minutes. An empty object is created. Well, we got this. This keyword, and you remember that, of this function is attached to this object. And then I'm going to skip on the third step because we're going to see that later. And then the object is returned. So basically, when you call a function this way with the new operator, an empty object is automatically created behind the scene with this keyword being attached to this function. And so now we can say to this object, sorry. And so now we can say this dot first name equal first name, and this dot birth year equal birth year. So again, when we do this, basically what we're doing is create an empty object behind the scenes. So this function is creating an empty object. It's attaching the this keyword to this object. So now we can do this.firstName equal first name, birth year equal birth year. And then the third step, let's keep it for now. And then the object is returned. So really, if now I print console.log Piero, why did I print it that way? Just in case you're wondering why this is uppercase, it's because when you define constructor functions, it's a good practice to do that, to differentiate them from other anonymous functions or arrow functions. So I know immediately when I see this person that this is used to create persons in the app. If I console.log this value, I can see that I have an object with birth year and first name. I can use this now again because I can say Sunil equal new person Sunil 1990. Console.log Sunil, and you can see that we got another object. So basically, we are adopting this pattern of defining a function, calling it with the new keyword, which is really doing the magic here, to kind of simulate OOP in JavaScript and be able to define a blueprint for an object and then create other objects based on that shape. So now we can create new persons, and for now this is not really useful, but suppose that we want to say something like const this.calc calculate the age, and I can say this is a function which returns this 2021 minus this dot birth year. And now for each person here, I can calculate its age, right? So I can say console.log Piero.calc age. I can call this function and I can see its result. And that's the same for Sunil. Right? So if I didn't use this pattern here, I would have got to do something like const Piero equal, and then, first name equal Piero, and then second name, and then, birth year. And then I would have got to do the same for Sunil. And, that would have been pretty boring, right? So this is kind of already solving a big problem for us of creating a blueprint for an entity and then create objects based on that blueprint on which we can perform some activities. Was that clear to you, chat, for now? Oh, Sunil is 1987. I will fix that.
No need to fix it, Piero. I'm fine with 1990. You can make me younger if you want.
So, okay, let's keep Sunil 31 years old. And now let's go back to prototypes. How does prototype fit in here? Well, let's start to say that doing this, so attaching this function here is no good. Why is that no good? Because now, whenever I create a new person, right, I will also be creating space in memory to store this function. So this stores calc age. This also stores calc age. So suppose that now, instead of just 2 instances of person, I have, I don't know, hundreds of them. Then I'm allocating space in memory, and that's not something good. So where can we store these functions so that each person that we create gets them? How can we do that? We can use something called prototype and prototype inheritance. So basically, on this person, you can understand that in JavaScript, every object gets its own prototype, right? So a prototype, basically, it's, again, another object. So as I mentioned, function, everything is an object in JavaScript, object. Person is an object. So I can say person.prototype.calcAge, right? CalcAge, oops, equal a function, and this function equal to this, let's say 2021 minus this dot birth year, and you can see that this is still the same of the this inside of person. So it's done automatically by JavaScript. And what I can do now is I can say const Piero equal new person Piero 1999. If I go back and print Piero, now the magic happens. You can see that I have my object, and then I got its proto property with the calc age. Do you remember when where we saw that first? On numbers. So we're kind of unveiling the mystery here, right? Because now I can do something like Piero.calcAge. I can call it. And why the freaking hell is that undefined? Let me see. Oh, I guess I should return this, of course. There it is. So I was able to call calcAge. So basically, now, what we did by using prototype are two things. The first thing is we avoided storing calcAge for every person which we create, right? And second, now every person we create gets access to the calcAge method, right? And I could do that also for other things like person.prototype.logger, and I can say this is a function. I can say it console.log this.first name. So basically, again, this prototype is joined to this person constructor function. So this is the same as this, no pun intended. And now I can also say console.log Piero.logger, right? And it prints Piero. So now we avoided storing calcAge for every person which we create, and every person we create gets access to the calcAge method. So this is really pretty convenient, right? Suppose that here, for example, we had a box like we did earlier in my example, as I was telling you, and now I can have like its width, I can have its height, and then I can have something like calc volume, right, for my program. But the thing that it's important here to understand is that this is the same mechanism that basically it's happening for the array, right? Because let's comment this out, and this will make you feel like a pro JavaScript developer. Let me uncomment this. No, this has to be. Now we can understand that basically inside of JavaScript, there is now an object called array. So const array equal a function, which is like similar to the one we did here. And so let's just write some code. And this array has its own prototype, array.prototype.filter array.prototype, and then it has something like .map. So this is how JavaScript internally created arrays. For example, it created an array object, and on its prototype it said, okay, attach this filter method, and then you can imagine it's a method which does what you know, and also the map does what you know. So that's basically how JavaScript allows us, when creating an array, to access methods like filter and map, because inside of it, there is an array object, which the people who created JavaScript created its own prototype and said, attach to this prototype the filter method, the map method, and all the other method which you can see inside of here. So flat map for each includes join, keys, and so that also kind of explains, right, why array, the prototype, the map. So now you know why you see that happening, because there is an array object, prototype, dot, and then on its prototype, there is the map method. Now, in case you're wondering why we don't have to do something like const numbers, const, I don't know, something like ages equal new array, well, actually, you can do it. This is a perfectly allowed syntax, but probably JavaScript has, I mean, not probably, it has some syntactic sugar that allows you to avoid having to do new, like we did with person. So, you know, basically this is the equivalent of this. Let's move this. And one other thing that I wanted to mention you is that there is a difference between the proto property and the prototype property. So array.prototype. Okay, and this is the fault in this is that these two names are super similar, but they differ. Because when you do something like, let's go back to the example that I built before. Oh, that would be a lot clearer to you. So, okay, so when I say person, the prototype, what I'm saying here is that every instance of person get this method inside of its proto, while when I say console.log Piero.proto, I'm accessing the prototype of Piero, right? So here I'm accessing, let's first print console.log Piero. So this is Piero. It has a prototype, proto property, which I printed down below. It has the calc age and the logger function, and these were defined using this syntax, person.prototype. And when you say dot prototype, you're basically saying every instance of person gets the method that you add to this prototype object. This can lead to confusion, but these are two different things, you know? And I think that, for example, since we were talking about, you know, this array example, we could also do something like array.prototype.academic equal function. I can say console.log my logs academic. And now if I uncomment this, I should be able, let me see. Yeah, you can see we did it. So basically the array object, the one which is, let's say, the base one from which, you know, we can create our own arrays, you can access its prototype and you can add things to it. So for example, I've added the function, and you can see that now if we print the proto of any array, really, it gets this academic function. So now we can say console.log numbers.academic, and you can see that it works. So basically, really, we hacked inside of the language of the system. And one last thing that I wanted to tell you about this, this thing about this prototype inheritance is the prototype chain. So basically, when you see that JavaScript is doing something like arrays.map, arrays.filter, I showed you how that is possible, but remember that first JavaScript will try to, and let's go back again to that example. Okay, we got Piero here. So we got Piero and its own prototype, right? Calc age logger. When we call, for example, Piero.calcAge down below, calc age. What JavaScript is doing internally is saying, okay, does the Piero object has this method calc age? And the answer is no, because you can see that we only have birth year and birth name. So it goes hunting for that property, for that function inside the Piero, so the Piero prototype. So then it finds it. And that's the same that happens when you create an array, because I could say, 1, 2, 3, 1, 2, 4, and then I could say R. I can print it, and it doesn't automatically have the map method inside of it, inside of this object, but it has it. It's inside its own proto. So basically there was this kind of chain, kind of like can you remember the scope chain when I told you that if the JavaScript engine doesn't find a value in the current scope, it goes in the outer, up to find for it. That's the thing with proto. If it can't find it in the object, it looks inside of its own proto, looking for it. So was that clear, chat? Chat, please give me an answer. Yes. So, do you have any question? Because the lesson doesn't stop here. The prototype part does, but you will have time for what I told you. So the special surprise. So if you don't have any other question, I'm going to stop the recording, and then we can go with our bonus section. I guess there is no question. That's great. I hope, because that was super clear to you. And I see that also some more people joined. Is there another lesson? Well, I'm going to start the recording so I can talk about it.